Hello and welcome. In this tutorial, we're going to talk about eigenvalues, and in this case, we are going to focus on the 2 by 2 matrices. So you are seeing on your screen that you have been given a matrix A and you have been asked to find the eigenvalues. So for us to find the eigenvalues, we are going to use this formula. We are going to say the matrix A, when we subtract the eigenvalues multiplied by the identity, because the eigenvalue is not a matrix itself, because it is a scalar. Eigenvalue is a scalar, so it is not a matrix. For us to convert it to a matrix, we must multiply it by the identity matrix. So in this case, we'll be having now and you are going to subtract the eigenvalue multiplied by the identity matrix of a 2 by 2 matrix, and this one should be giving us a 0. We are going to go further. When we multiply a scalar by a matrix, we are going just to affect where we have the whole numbers, because any number multiplied by 0 is a 0. So we'll be having lambda here, 0, 0, lambda, and this one should be giving us a 0. So when we want to subtract matrices, we are going to say that we'll be having on row 1, column 1, we are going to subtract this value there. So we'll be having 7 minus lambda, and this one we are going to subtract this one. So 3 minus 0, you're going to get 3. 3 minus 0, you're going to get 3. And this one will be having negative 1 minus lambda. And this one should be giving us 0. So the whole case is now to find the determinant of the same. So it is now 7, the leading diagonal, of which we have this one as the leading diagonal. 7 minus lambda, you're going to multiply minus 1 minus lambda. Then we're going to subtract 3 times 3, of which that one is 9. And this one should be giving us a 0. From that point, we're going to say that we are going to multiply this. We are going to open these brackets. So we are going to say 7 multiplied by negative 1, it is negative 7. And 7 by negative lambda is negative 7 lambda. Negative lambda multiplied by negative 1, it is plus lambda, because negative times negative is a positive, and again minus lambda times minus lambda is now positive lambda squared. Subtracting 9 should be giving us 0. So we'll be having lambda squared. So these are like terms. So you'll be having minus 6 lambda. Then minus 7 minus 9 is minus 16. Should be giving us a 0. Then from that point, we are going to solve this one as a quadratic equation. We can use any method. So in this case, I'm going to use factorization, and I'm going to find two numbers whose product is negative 16 and the sum is negative 6. So I can say that the factors, those two numbers, I'll call them factors. The factors are, I can call them negative 8 and positive 2, because negative 8 multiplied by positive 2 is negative 16, and negative 8 added to 2 is negative 6, meaning we are correct. So you're going to say lambda minus 8 and lambda plus 2 is equals to 0. I just went ahead to this point, but for maybe let me do a recap of how we got here. So we'll be having lambda squared minus, so this case we are going to replace this case with these two factors. So we'll be having minus lambda squared plus 2 lambda minus 8 lambda minus 16 is equals to 0. So we have replaced this, because when we find the value here, it is still going to give us negative 6 lambda. So we are going to pair them, and this one is now lambda into lambda plus 2 minus 8 into lambda plus 2 is equal to 0, and this one will be lambda minus 8, and again lambda plus 2. This one is equals to 0, and this is how we arrived at this point. So we are going to say lambda minus 8 is equals to 0. This implies that lambda is 8, and again lambda plus 2 is equal to 0. This implies that lambda is equal to negative 2. So you can say that lambda 1 is 8 and lambda 2 is negative 2. That is how you obtain the eigenvalues of any matrix. Thank you for watching.